Let me put the screen back up.
Okay.
Okay. So here we go. We are going to look at all possible roots. So we're going to state all the possible rational zeros first, which we did in the last lesson. And then we're not just going to find rational roots. We're going to find rational roots, which are things that are real numbers but can be written as a fraction. Irrational numbers, meaning we could have some square roots and things. And also complex roots, which would be the imaginary ones with I. So we're going to find all of the roots. If you have a cubic polynomial with third power, which all of these are going to be, we're going to stick with cubics for right now. Anytime your highest power is 3, that means that there are 3 roots. You may not be able to see all of them on a graph because you're only going to be able to see the real ones on the graph. Only maybe one will be rational, but there's going to be 3 roots of some type. So we'll start just by reviewing how we get the rational roots. So the rational roots, the possible rational roots are going to be factors of the last term, which is 1, over factors of the first term, which is 4, and then you can do positive or negative on those. So 1 has to be on the top, and then we have to think about what goes into 4. So possibilities, I could have plus or minus 1 over 1, which would be 1. What else goes into 4? 4 would go into it, and so would 2. So plus or minus 1/2, plus or minus 1/4. So those are possible rational roots. So these are possible rational roots. So this would be possible roots that don't have square roots, that don't have I. And then what we did, instead of checking all 6 of these, we actually have been using our graphing calculator to narrow this down. So I'm going to go into my y equals menu and put in this function, 4x to the third plus 9x squared plus 6x plus 1. And then if you have your screen on something weird, a good place to start with the first one is to do zoom and do number 6 just to get a standard window. None of our numbers here are very big, so we don't need anything bigger than that. And it looks like it crosses in a couple of places. So we can look and see what it looks like. It looks to me like it's crossing at -1. We can check that using this graph. If you hit the trace key, I can actually type -1, and it sort of gives you a prompt. And if I hit enter, it'll tell me what the y value is, and that's 0. And we can tell just by looking at it, it just kind of sits right there. So 1 is a root. I'm sorry, -1 is a root. And then there appears to be another one over here a little ways. So let me take it out of trace mode. And you have to kind of decide if you think that's going to be -1/2 or -1/4. What do you think? We could try -1/2. Oops, I didn't mean to do that. So go back to graph. If I hit trace, I could do -1/2 and type that in using my division key. And that gives me -0.25. It's not a 0. I can try -1/4 really quick. And that is a 0. And those are the only places that it looks. Now, if you look at this carefully, at -1, you can see that this little part of this little local maximum just sits where it touches the x-axis. When you have that, that counts as 2 roots.
You wrote a 0.
I wrote a 0. Okay, so -1/4 is what I meant to write, not the 0, which is the y value. Sorry. So -1, because it sits at -1 but doesn't actually cross all the way, is a double root, which means that it has multiplicity of 2. It counts twice. Question?
Never mind.
Multiplicity of 2. And you can see it better if we zoom in, so I'm going to do that really quick. If you're zooming, you can use your arrow keys to kind of figure out where you want the center of your graph to be. I'm just going to put it like right there. And you can see it just sits, it just touches the x-axis, it doesn't cross. that's when you know you have a double root. So the -1 counts as 2 roots. And then it actually goes through at -1/4. That counts as 1 root. And I can actually stop without searching for anything else. And I will know then that this is all of my answers. All of the roots for this problem ended up being rational. Sometimes that happens. Sometimes it's not. Depending on what kind of a polynomial you're looking at, sometimes they're all imaginary. But this is where we start. It's with what we did in the last lesson. Okay? So the -1 counts as 2 roots, and -4 is 1 root. That's all 3. And once you have all 3, we can stop, because that's the power. Okay, let's go to number 2. Okay, so on number 2, we're going to start with the possible rational roots. So we're going to start with the plus or minus factors of 1 over factors of 5. Mark. So that's going to be 1 is the only thing that goes into 1, so I could have 1, and 1 goes into 5. But 5 also goes into 5, so I could have plus or minus 1/5. So that gives me 1, 2, 3, 4 rational roots that actually work.
Must be computer call.
So we're going to check for rational roots first by graphing this function. 5x to the 3rd plus 5x squared plus x plus 1. And I'm still zoomed in, which is okay because we're checking 1s and 1/5.
Looks like a -1.
So it looks like -1 is the only rational root. So -1 is one of my answers. I'm going to put that down and box it. That's a rational root. So what we're going to do with that is we are going to figure out, if I take out the factor that goes with that, what's left to find the other answer. So if -1 is a root, that means if I take this polynomial and factor it, that means x plus 1 is part of the factor. We need to figure out what else would be there. Since it's x plus 1, we don't have to use polynomial long division. We can use synthetic division to find the rest of this. So what we're going to do is we're going to use this polynomial and -1 and set up synthetic division to try to get some more information. So we're going to take the coefficients out of here. So 5, 5, 1, and 1. Leave a little space, set up our line. So the first step is just to drop down that first 5. And then we multiply -1 times 5 is -5. Add these together, we get 0. 0 times -1 is 0. 1 plus 0 is 1. 1 times -1 is -1, and we get 0. And remember to box this last part, that's the remainder. So we were right in saying that -1's a root. We just checked it. And then this information is going to give us what the rest of that polynomial would be. So this would be, there's no x term, but this would be 5x squared plus 1. You could put a 0x in the middle, but that's what we would get out of this, and that's what would go up in these parentheses up here. So we know this part's giving me -1. Looking at the graph, and even if you went back to a regular window, I could do a zoom 6 really quick, just in case I was worried I messed something up. It isn't crossing the x-axis any other place. That means there's only one real root. Everything else has to be imaginary because it's not touching the x-axis anywhere else. So this is the part we're going to use to find the other roots. Since there is no x term on this, we can set this up very simply into an equation to find the roots. We can do 5x squared plus 1, and we want to know what x is going to make that equal to 0. They call them zeros sometimes instead of roots. That's what's in our directions, and we're going to figure this out. If there were an x term, I would either have to factor this, which we know it's not factorable because we'd be getting something else, or I could use quadratic formula, but since there's no x term, we could actually just solve for x in the more traditional algebraic way. So subtract 1 from both sides. Get 5x squared equals -1. Divide by 5. And we get x squared equals -1/5. So to solve this, you've got to take the square root of both sides. When you square root this, what you're going to do is you're going to square root the top and square root the bottom. Now the square root of -1 is just I. And then I have a square root in the bottom, which is not okay. We've talked about that before. So we multiply by the square root of 5 over the square root of 5. You're going to get I square root of 5 over 5. And we also need to remember to put plus or minus on the front. It could be positive and negative roots. Your imaginary roots always come in pairs. Always. So this counts for a positive root and a negative root. So there's 2 roots. There's one more. Since this is a cubic, that's all 3 roots, and I know that I'm done. So I boxed this. That's 2. There's one more. We've got all 3 roots. Okay, I know this is not the most fun lesson we've ever done, but it's using all the stuff we've worked up to this point. This is what you use when all of our other solving methods don't work. I can't solve this using anything else, so we start going into using what we know about finding roots. All right, so here's our next one. We're going to go through and find the possible rational roots first. A cubic's always going to have 1 because of the way it's shaped. So we would have plus or minus factors of 1, because that's the last term, over factors of 2, which is the first term. So this and this is what we use to figure out this possible rational roots. So the factors of 1 would just be 1. The factors of 2 are 1 and 2, so we make different combinations of fractions. So I could have 1 over 1, that'd be plus or minus 1. Could also have 1 over 2, just plus or minus 1/2. This gives us something to choose from. I could check all 4 of those using synthetic division. That was how we did stuff back in the olden days. But now that we have graphing calculators, we can check these a little bit faster. These used to be a lot worse, believe it or not. Minus x squared minus 2x plus 1. Okay, so we have this. We're going to graph it and see if we can see where it crosses the x-axis. So it looks to me like I have 3 real roots because it's crossing the x-axis in 3 places. If you want to zoom in to see it a little bit better, we could do zoom in and just zoom in on the origin, and that'll give us a little bit clearer picture of where things are at. It looks to me like -1's going to work, and like +1's probably going to work, and probably +1/2. So we can check that really quick. We can put those in. If you hit trace, do -1, make sure it's a 0 down here. We can put in +1, make sure that works. Put in +1/2, or you could type that as 0.5 and make sure that that works as well. And that is all 3 of our roots. And so we would have -1, +1/2, and +1, and we didn't have to do anything else with it. Now, what could we do with this? These are solutions that you could have to an equation. You can also use to factor this. So I could use this to factor the polynomial if I needed to do that. I could have x plus 1, x minus 1/2, x minus 1, and then you have to bottoms up any fractions, which means you'd get 2x minus 1. And so this is something we learned when we did our factoring stuff, how roots and factors. So if we needed to factor something crazy like this, which sometimes comes up, when you're factoring crazy stuff in like a college algebra setting, they will actually use this as a means to factor some weird looking things. In case you need to cancel out something in a fraction or rearrange an equation, it sometimes happens. For what we're doing, we're just looking for the roots. Okay, so let's go to number 4. This one's slightly more exciting. So to look for the possible rational roots, we're going to go for the first term and the last term. So our possible rational roots are going to be plus or minus factors of 2 over factors of 4. So the factors of 4 are 1, 2, and 4. The factors of 2 are 1 and 2. So those are the combinations we're looking for. So I'll start with just 1 on the top. I could have 1 over 1, which would be plus or minus 1. I could have 1 over 2, which would be plus or minus 1/2. Could have 1 over 4 plus or minus 1/4. And then I could go to the 2's. I could put the 2 on top. So 2 over 1 is plus or minus 2. 2 over 2 would give me 1, which I already have. And 2 over 4 would reduce to 1/2, which I already have. I'm going to move this over here so I have more room for the next part. Okay, so there are, if you do the positives and negatives, you have 8 possible roots. You could test using synthetic division. We're just going to use the calculator.
Yes.
So if we go into the y equals menu, we can put in our equation, our function here, 4x to the third minus 8x squared plus x minus 2. And I'm still zoomed in, but I think that's okay because all of these numbers are small. And it looks like, for at least what we have right here, that it's only crossing at 2. I'm going to write that down and I'll check it. So trace, I'm going to put in 2 and see if that works. And you can kind of see this other little loop over here. If I go back to a standard window, you'll be able to see that it doesn't come up far enough for this other little piece to hit the x-axis. What that means is for this little part of the graph, we're going to get 2 imaginary roots. So 2 is one of my answers. I'm going to write it down. I'm going to box it. I know that is the only rational root that's going to work. So then,
But guess what? We're not done.
we are not done. So if it's 2, when I go to put it in
X
parentheses,
minus 2.
it's x minus 2. I'm glad you guys are getting something out of this. And then we want to figure out what the other part is so that we can find the imaginary roots. So to do that, we're going to put 2 in the little box and do synthetic division so that we can figure out what's left over when we divide this out of this polynomial up here. So we'll take the coefficients 4, -8, 1, -2, and see what we get. So I'm going to pull down 4. 4 times 2 is 8, -8 and 8, 0. 0 times 2 is 0.
The answer is yes.
0 plus 1 is 1. 1 times 2 is 2. And we already knew it was a root. It's yes. What does this part down here give us? The other numbers. So let's put that back with the x's and make it into a polynomial. What polynomial do we get out of that? 4x squared plus 1. So the x term's missing again, which makes this, I purposefully did that so that this was not super difficult to solve. So 4x squared plus 1, we need to set this equal to 0 to find the other part. So 4x squared plus 1 equals 0. We're going to solve that. So we don't have to use quadratic formula. I set it up so we didn't have to, but there may be times when we do. So I'm going to have 4x squared equals -1. Divide both sides by 4. I get x squared equals -1/4. I like this one because when we square root the top and the bottom, x is going to be plus or minus the square root of -1, square root of 4. Both of those I can figure out. It's just going to be plus or minus I for the top and 2 for the bottom because the square root of 4 is just 2. I didn't have to do anything super weird.
You just squared it.
Just square root 4 because it's a perfect square. So that's our other 2 roots. If you have roots with I, they always come in pairs. So if we're doing a cubic, you're going to have 1 real root for sure, and then the other 2 could both be real or they could both be imaginary. But the imaginary, if you have it, always come in pairs. You're always going to have a plus or minus situation because that's how they work. Okay.
So how do you know? How do you know if there's an imaginary root there or not?
Because it's negative when you square root. The square root of negatives gives you an imaginary number.
No, like way in the beginning. So
Way in the beginning.